The next defined discrete probability distribution that we're going to look at is called the Poisson distribution. Poisson distribution is about a process. Poisson process is number of arrivals or number of successes over time or space. So you can say one possible example is in 1 hour, how many customer service calls will you receive in the switchboard? How many possible values are 0, 1, 2, 3, 4, 5. So here there is no limit like in binomial. Binomial, you're limited by the number of trials. You cannot have more success than the number of trials. So here, since the limit for counting number of success is based on a space of time or geographical space, there is no limit, and therefore what we have can be called as a countable infinity. You're able to count. You're able to get started with the counting. Of course, you're not going to be able to end it, but you can count from one possible value to the next possible value, 0, 1, 2, 3, and so on. And another example, this is time-based example, is how many calls you'll receive in a space of time. Another example would be like if you have fiber optics cable. Okay, so in 1,000 meters of fiber optic cable, how many faults will be there? So this will be not a time-based interval, it is distance-based interval or length-based interval. Or you can also have area-based interval. Suppose if you have carpet. Okay, so in 1,000 yards of carpet, square yards of carpet, okay, how many blemishes will be there? Okay, so those are examples of Poisson distribution, and Poisson distribution is very often used in queuing models. It's a very important distribution. The condition that must be true for Poisson distribution is that the average number of success, okay, is proportional. Okay, like for example, if the average number of customer service calls in 1 hour is 10, okay, then in 2 hours it must be 20. In 3 hours it must be 30. So it must be proportional. You can't have a process where in 1 hour it is 10, in 2 hours it is 15. Okay, then that is not Poisson distribution. So this is the only, and the arrivals are independent. Okay, so that also must be true. Then the probability is given by this formula. Probability of x, okay, number of arrivals, is lambda to the power of x, okay, where lambda is the average number of arrivals per unit time or interval or space, whatever the basis is. So that is the average arrival rate or mean arrival rate. So that's lambda. So lambda to the power of x, e to the power of minus lambda divided by x factorial. Okay, the e here is a constant like pi. Okay, the value of the constant is 2.71828, and it's a irrational number. Okay, let's now move over to Excel. Okay, so the process is count number of events during specified range of time or space. Okay, here are some examples. Okay, and this is the formula. Okay, where lambda is the average number of events, yes, number of successes in a specified duration of time or space, and e is a constant. So you can use the Excel has a function called exp. Yeah. So if you do exp1, that will be e to the power of 1. That will give you the value of e. So there it is.